Hello class. As you can see in this video, we're starting with some of the very basics of the procedural programming class that we're following through here. This is from chapter 1. Usually I won't lecture from slides. However, for this first week and some of the second week, we'll look at slides because the information lends itself better to that. In future, we'll have more videos where it's more demonstration. You'll see coding examples as you are developing your skills at writing programs. So very excited about this, but let's start with this simple question. What is a computer? So you might be thinking, well, I know what a computer is, but think about, all the different types of computers there are, and how would you define specifically what a computer is in its most basic level? The simplest explanation of what a computer is just to use the name. It's one that computes, and a computation is really just calculation. And so you can think of it like calculating, solving problems using math. That is what a computer does. And this doesn't have to be an electronic device. Originally, computer was a job title. You can see here on the right that this is the computer room, and there's no electronic computers in this room. These ladies here are actually performing calculations at NACA, which later became NASA, for research. And so that is really cool that a computer is actually not the electronic device. This helps us out when we think about computer science. When we're studying computer science, we're not thinking about the computer, we're thinking about the calculations and how we can represent information, manipulate it to do problem solving and help us out around the world in various ways. But if we're thinking about an electronic computer, a programmable computer, then it always does four things. So there's four things that an electronic computer always does, no matter what it is, whether it's a cell phone, a thermostat, a laptop computer, anything like that, four things. And so the first thing is it retrieves numerical data. Secondly, stores numerical information. Third, it processes that information. And so this is done in arithmetic and logical operations. So again, math using numbers, and outputs that numerical data. And so here you can note a trend. A computer only works with numbers. So whatever you see on the screen, whatever music's coming out of your speakers, it's all processed and handled and represented internally and shown as numbers. Just the representations we manipulate help us out in the physical world by making it what we would like to see or experience. And so that's really cool. That a computer, as amazing it is what it's doing, all it really is doing is simple calculations, but it's doing thousands of them usually a second to make these representations that we can enjoy, such as this video that you're watching now. Now, computer systems involve hardware and software, and we're going to talk about those components individually, but hardware is the physical stuff, the hard stuff that represents the computer, and the software is the systems that run on the hardware. So that is the instructions that will have it perform and the data involved with that. And so hardware is always divided into four primary components. The input and output devices. So we get input from a system and then we want to process it and output the results. And so we need input and output devices. And then the CPU, central processing unit, which does the majority of the calculations. Main memory, which stores stuff to be worked on. And secondary storage, which stores it more long term. So let's talk about each of those more individually. First of all, let's talk about input devices because that's the first step in the process. You need to get some input to be processed. And input devices that can be keyboard, mouse, they can also be secondary storage a little bit if you think about getting input from a CD-ROM drive or a flash drive or the internet. So those would all be input devices to your computer system. Now, output devices display the results, and it doesn't have to be just displayed on the screen. It can also be stuff like 3D printed stuff or printed on paper or output to the speakers or even motion. So if you're dealing with robotics, output might be to move your robotic arm or to steer the vehicle left or right. And so those are all output of the results. Now, The processing step happens in the CPU, and so that is a very important step to the computer. The central processing unit is considered the brain of the computer. That's where all the information is processed. It's usually the most expensive piece of hardware, and it carries out these arithmetic and logical operations. Now, arithmetic, that's math, that's addition, subtraction, division, and so forth. Logical operations are like, if this is true and this is true, then do this. And so, for example, if it's raining, then wear a rain jacket or have an umbrella. That would be an example of an arithmetic operation. You're going to pull out that umbrella if it's raining. Now, these are generally carried out on a single chip, and the first chip that encompassed all the central processing unit's functions was the Intel 4004, which was released in 1971, and you can see on the right there that chip. On the modern day, we have a modern CPU, the AMD Ryzen, as this example, and you can see it looks very similar. It's got some kind of silicon on the top with the instructions in it and the different operations, and lots of pins coming out of the bottom. And those pins are how it connects and sends and retrieves information from the rest of the computer. And so you can see the modern CPU has a lot more pins. It also does a lot more processing, but having more pins allows you to have a greater amount of data throughput faster, because our modern CPUs are much faster in handling the process of operations. They can do more operations too, but generally about the same number of operations are performed from the original 18404 and the modern CPU, which is pretty wild. There are new operations, but generally the most used ones are pretty much the same from way back then. Main memory, also called generally random access memory or RAM, is important because the CPU cannot handle information from input devices directly. And so the information from the input device needs to be loaded into RAM and then handled in memory for the CPU to perform the calculations. So the CPU has a direct connection to this main memory. When a program is run, the first thing that needs to happen is it needs to be loaded into main memory and then it can be executed. Data must be brought into main memory before it can be manipulated. And main memory is volatile, meaning when the power is off, it's wiped out. And when the computer first turns on, there's nothing in main memory. And so everything must be loaded into memory and then manipulated and then saved elsewhere if you want to hold on to it more permanently. And that's where secondary storage comes in. Main memory is an ordered sequence of memory cells. So we've got this long list of information. How do we locate what we need out of it or store something in it? Well, we've got addresses. So you can see on the right there a sequence of cells, and at location 1000, there's 54 being stored. And so we can access 54 by looking at what is in location 1000. So this is how we address and access and store information in main memory. Now, main memory is also sometimes called primary storage or physical memory. And so that's to note why we call secondary storage because main memory is the primary storage. Each cell of memory can contain information, but it can also contain instructions. And either way, they're represented as numbers. Secondary storage is where the device can store information more permanently. So examples would be hard drives, flash drives, CDs, tapes. Believe it or not, tape drives are still widely used in industry because they're very cheap and you can hold a ton of information on them. They're great for backups because you can generally just wind back the tape and see what information was stored in a linear fashion. So I still include that in this information, even though you might think, who uses tapes these days? Well, they're still very commonly used, and new versions of these tape drives are still being produced. Pretty wild. The hardware of a computer is not very useful without software. Software is what instructs the computer on how to behave, how to take that input, what to do with it, and how to produce the output. And so software are the programs that do specific tasks on the hardware. Now, there's two types of software. There's system programs that control the computer overall, and there's applications that perform specific tasks. And so a system program oftentimes is an operating system. An operating system monitors the overall activity of a computer and provides services such as memory management, input and output activities, and storage management. Common operating systems are the Mac OS, Windows, Linux, Chrome OS, which you have on your Chromebooks, and Android or iOS, for examples. So these programs work directly with the hardware. Applications perform a specific task, such as word processing or web browsing, your web browsers, or games. All of those do a specific task. They run inside a system program, an operating system. And so they don't know exactly what hardware you have generally, and they don't have control directly to the hardware. They say, here's what I want to do, and the operating system allows them to have access to specific resources and maps that to when they have that access, etc. There's a lot more detail we can go into that, and so if you're interested, definitely take the architecture and operating system courses to find out more about how this process works. But in summary, we've got system programs that work directly on the computer and manage its hardware, and applications which run inside the system programs. And when that happens, we generally call the system program an operating system. Now, in this class, we'll focus on developing applications that run inside the hardware, and we'll take advantage of the resources and options that the operating system gives us, so we don't have to write exactly how to interface with the hardware. That's a very great thing to do, but let's just take advantage of what's already there for us and create new applications that can do what we want to do within that operating system. So in summary of what we just learned about what a computer is, we can say a programmable computer is an electronic device that can perform arithmetic and logical operations. And in order to do this, it needs to have hardware and software. And the hardware involves the central processing unit, which is the brain of the computer, primary storage, which is called main memory, and it's volatile, meaning that when it's turned off, that stuff goes away. Secondary storage, which stores information more permanently, such as disks, and input and output devices. Operating systems are the programs that monitor the overall activity of a computer and provide additional services. Applications are programs that perform specific tasks within an operating system. Next, we'll look at how a computer understands information and instructions and how we can write programs for the computer using this information.